Look up into the daytime sky. What do you see? Take a moment, truly observe. Let your eyes adjust to the brightness and consider the vastness beyond the blue. What is the first thing that captures your attention? Is it the color, the clouds, or something else entirely? A brilliant disk of light, so familiar, so constant. It's our sun, the source of all life on Earth. We often take it for granted, this radiant sphere that dominates our sky. But what is it really? What makes it shine so brightly day after day, year after year? To us, it is unique, the anchor of our world, the source of all warmth and light. It dictates our seasons, our days, our very existence. Without it, Earth would be a frozen, desolate wasteland. We are inextricably linked to this star, our fate intertwined with its own. Yet in the grand cosmic theater, our sun is just one star among hundreds of billions in our Milky Way galaxy alone. Imagine the sheer scale of it all. Billions upon billions of stars, each a sun in its own right, scattered across an immense spiral of light and dust. Our sun, a single point of light in this vast cosmic ocean. And there are countless galaxies beyond our own, each brimming with their own stellar populations. Each galaxy a universe unto itself, containing billions more stars, and potentially countless more planets. The numbers are so staggering, they are almost impossible to comprehend. It is in many respects an average star, a G-type main sequence star, common throughout the universe. A yellow dwarf, burning steadily, neither too hot nor too cold, just right for fostering life as we know it. But what does it mean to be an average star in such an extraordinary universe? But this seemingly ordinary status belies its extraordinary significance for us, for life on Earth. It is the perfect star for our planet, providing the precise amount of energy needed to sustain a delicate balance. A balance that has allowed life to flourish for billions of years. It is the silent, steadfast engine of our existence, a celestial body of immense power and complexity, a churning ball of plasma held together by gravity and fueled by nuclear fusion. It radiates energy in all directions, a tiny fraction of which reaches our planet, enough to power our world. This star, our sun, appears deceptively simple from our vantage point millions of kilometers away. It hangs in our sky, a serene orb of light that rises and sets with comforting predictability. We mark our days by its passage, our lives governed by its rhythm. We feel its warmth on our skin. We see its light illuminate our landscapes, and we plan our lives around its daily journey. From the moment we wake until we fall asleep, the sun's influence is ever present, shaping our world in countless ways. It is a constant companion, a silent witness to our lives. But this tranquil appearance masks a truly dynamic and violent reality. Beneath the serene surface lies a world of unimaginable energy and chaos. Solar flares erupt, coronal mass ejections hurl vast amounts of plasma into space, and the sun's magnetic field twists and writhes in a constant dance of power. Deep within its core, unimaginable pressures and temperatures fuel a continuous nuclear furnace. Hydrogen atoms are fused together to form helium, releasing vast amounts of energy in the process. This is the engine that powers the sun, the source of its eternal flame. It is a seething, turbulent sphere of plasma, far more complex and energetic than its calm facade suggests. The surface of the sun is a roiling ocean of superheated gas, constantly churning and shifting. Sunspots appear and disappear, magnetic fields tangle and snap, and the entire star pulsates with energy. It is a paradox, an ordinary star, yet the extraordinary architect of our world, a simple disk in the sky, yet a colossal fusion reactor. A seemingly unremarkable object, yet the very foundation of our existence. This duality is at the heart of the sun's mystery. The sun's apparent ordinariness is precisely what makes it so suitable for nurturing life. It's not a volatile, short-lived blue giant, nor a dim, cool red dwarf. Blue giants burn through their fuel incredibly quickly, lasting only a few million years. Red dwarfs, on the other hand, are much smaller and cooler, and can last for trillions of years, but they often emit strong flares that could be harmful to life. Its stability, its longevity, its consistent output of energy over billions of years, have provided the perfect conditions for life to emerge and evolve on our planet. This balance, this cosmic serendipity, is a crucial part of our story. The sun has been shining steadily for billions of years, providing a stable environment for life to take hold and evolve. This is a rare and precious gift. We orbit a star that is, in galactic terms, unremarkable. Yet for us, it is everything. Our entire world revolves around this single star, our lives dictated by its light and warmth. We are bound to it by gravity, forever circling in its embrace. It is the difference between a barren rock and a vibrant living world. Its gentle light has guided evolution for eons, shaping every creature, every plant, every ecosystem. From the smallest microbe to the largest whale, every living thing on Earth owes its existence to the sun. Understanding this duality, the sun as a common star and as our unique life-giver, is the first step in appreciating its profound role in the universe and in our own lives. It is a humbling realization to understand that we are both insignificant in the grand scheme of the cosmos, and yet utterly dependent on this one particular star. It invites us to look beyond the familiar and delve into the extraordinary science of how stars like our sun are born, how they live, and how they eventually die. To understand the sun, we must understand the life cycle of stars, from their formation in vast clouds of gas and dust to their eventual demise as white dwarfs, neutron stars, or black holes. This journey will take us across unimaginable scales of time and space, from the fiery birth of the sun in a cosmic nursery to its eventual, distant demise. We will explore the vast nebulae where stars are born, the turbulent interiors of stars where nuclear fusion takes place, and the dramatic events that mark the end of a star's life. It is a story not just of a star, but of our home, our origins, and our ultimate connection to the cosmos itself. We are all made of stardust, the remnants of stars that lived and died billions of years ago. The elements that make up our bodies, our planet, and everything around us were forged in the hearts of stars. We are, in a very real sense, children of the sun. At the very heart of our solar system, a celestial furnace of unimaginable power, our sun beats with an immense and relentless energy. It's a powerhouse that dwarfs anything we can create here on Earth, a constant source of light, heat, and life-giving radiation. This fiery sphere, seemingly unchanging from our distant perspective, is in reality a scene of constant turmoil and activity, a dynamic engine driving the very existence of our world. The sun's influence extends far beyond mere illumination. It dictates our climate, fuels our ecosystems, and governs the movements of the planets themselves. It is the ultimate source, the prime mover, the unwavering beacon in the vast cosmic ocean. This power does not come from burning fuel in any conventional sense, like a giant bonfire in the sky fueled by wood or gas. The sun's energy source is far more exotic, far more efficient, and far more enduring than any chemical reaction we can replicate. Imagine trying to build a fire that could burn for billions of years, releasing an unfathomable amount of energy every single second. It's simply not possible with ordinary combustion. The sun operates on principles that delve into the very fabric of reality, tapping into the fundamental forces that govern the universe. Instead, it originates from a process far more fundamental, far more potent: nuclear fusion. This is the same process that powers hydrogen bombs, but in the sun's case, it is carefully controlled by the immense gravity and pressure at its core. It's a delicate balance, a cosmic dance between opposing forces that allows the sun to shine steadily for eons. Understanding nuclear fusion is key to understanding the sun's power, and indeed the power of many other stars in the universe. It's a process that transforms matter into energy, following Einstein's famous equation, E=mc2, unlocking the immense potential locked within the atom. Deep within the sun's core, a region of unimaginable density and pressure, where temperatures soar to an astonishing 15 million degrees Celsius. That's nearly 3 million times hotter than boiling water. At these extreme temperatures, atoms are stripped of their electrons, forming a plasma, a superheated soup of charged particles. This plasma is constantly colliding, interacting, and undergoing nuclear reactions. It's a chaotic environment, but within this chaos lies the source of the sun's incredible power. The core is a realm where the laws of physics operate at their most extreme, pushing matter to its limits and unlocking the secrets of the universe. And pressures are almost unimaginable, far exceeding anything we can create in our laboratories. Hydrogen atoms are constantly being forged into helium. This isn't just a simple chemical reaction, it's a transformation of one element into another, a process that releases tremendous amounts of energy. The hydrogen nuclei, or protons, are forced together with such force that they overcome their natural repulsion and fuse to form a helium nucleus. This fusion process releases energy in the form of photons and other particles, which then begin their long journey to the sun's surface and eventually out into space. This transformation releases a truly staggering amount of energy. Each fusion reaction releases only a tiny amount of energy, but when you consider the sheer number of reactions happening every second within the sun's core, the total energy output is simply mind-boggling. It's an amount of energy that is difficult for the human mind to truly grasp, a testament to the power of nuclear fusion and the scale of the sun itself. This energy radiates outwards, powering not only our planet but the entire solar system. Every second, our sun converts about 600 million tons of hydrogen into helium, a process that releases an amount of energy equivalent to billions of hydrogen bombs exploding simultaneously. This is the sun's constant, unwavering output, the engine that drives life on Earth. The sheer mass of hydrogen being consumed is staggering, yet the sun is so massive that it can sustain this rate of consumption for billions of years. A rate of consumption that boggles the mind, yet it has enough fuel to continue this process for billions of years more. Scientists estimate that the sun is about halfway through its lifespan, meaning it will continue to shine for another 5 billion years or so. This gives us a sense of the immense timescale on which the universe operates, and the incredible stability of our sun as a source of energy. It's a comforting thought, knowing that we can rely on the sun's energy for the foreseeable future. This incredible fusion reactor, located 150 million kilometers away, is the ultimate source of nearly all energy on Earth. From the food we eat to the fossil fuels we burn, almost all of our energy can be traced back to the sun's nuclear fusion reactions. Even wind energy is ultimately driven by the sun as it heats the Earth unevenly, creating pressure differences that drive air currents. The sun is the foundation upon which our entire energy economy is built. The sunlight that warms our planet, drives our weather patterns, and fuels the process of photosynthesis in plants, the very foundation of our food chain, is a direct product of these nuclear reactions. Without sunlight, plants would not be able to convert carbon dioxide and water into sugars, and life as we know it would simply not exist. The sun's energy is the lifeblood of our planet, the driving force behind all biological processes. Is a direct product of these nuclear reactions occurring 150 million kilometers away. That's a vast distance, yet the sun's energy travels across this expanse in just 8 minutes, reaching our planet and bathing it in life-giving light. The sheer speed and efficiency of this energy transfer is remarkable, a testament to the power of electromagnetic radiation. It's a constant reminder of the sun's immense power and its vital role in our existence. Think about it. The gentle warmth you feel on a sunny day began its journey as a high-energy photon born in the sun's violent core, a place of unimaginable heat and pressure. This photon, a tiny packet of energy, is the product of nuclear fusion, the engine that powers our star. It's a remarkable journey, from the heart of the sun to the surface of our skin, a testament to the interconnectedness of the universe. That energy then embarked on a long, tortuous path through the sun's dense interior, a journey fraught with obstacles and delays. The sun's interior is not empty space. It's a dense plasma that constantly absorbs and re-emits photons, scattering them in random directions. This process slows the photons down considerably, delaying their escape from the sun, taking tens of thousands, even hundreds of thousands of years to reach the surface. Imagine a photon being bounced around inside the sun for centuries before finally escaping into space. This long and arduous journey is a consequence of the sun's density and the way energy interacts with matter. It's a fascinating example of how the sun's internal structure affects the flow of energy. Before traveling through space to greet our world, once the photon finally reaches the sun's surface, it is free to travel through the vacuum of space at the speed of light, embarking on the final leg of its journey to Earth. This journey takes only about 8 minutes, a tiny fraction of the time it spent trapped inside the sun. It is a constant, life-sustaining flow, a gift from our star. The sun's energy is not just a source of warmth and light. It is the foundation of our entire ecosystem, the driving force behind all life on Earth. It's a gift that we often take for granted, but without it, our planet would be a barren and lifeless wasteland. The sheer scale of the sun's energy output is difficult to comprehend. It's a number so large that it's almost meaningless to try and visualize it. Scientists use various units to measure the sun's energy output, such as watts, joules, and ergs. But even these units fail to capture the true magnitude of the sun's power. It radiates more energy in a single second than humanity has consumed throughout its entire history. Think about all the energy we have used since the dawn of civilization. All the wood burned, all the coal mined, all the oil extracted, and the sun produces more than that in just 1 second. This comparison highlights the truly staggering scale of the sun's energy output. This energy not only illuminates and warms Earth, making our planet habitable and allowing liquid water to exist on its surface, but also holds the entire solar system together through its immense gravitational pull. The sun's gravity is what keeps the planets in orbit, preventing them from drifting off into the vastness of space. It's a force that extends billions of kilometers, shaping the structure and dynamics of our solar system. Planets, asteroids, comets, all the celestial bodies in our solar system, from the largest gas giants to the smallest icy fragments, all dance to the sun's gravitational tune, orbiting in an intricate, predictable ballet. The orbits of the planets are not perfect circles, they are ellipses, and their speeds vary depending on their distance from the sun. This complex dance is governed by the laws of gravity, and it has been studied and understood for centuries. The sun is not just a passive source of light, it is not a static, unchanging object. It is the dynamic center, the gravitational anchor, and the energetic heart of our cosmic neighborhood. The sun is constantly changing, undergoing cycles of activity that affect the entire solar system. These cycles are characterized by changes in the number of sunspots, solar flares, and coronal mass ejections. Its influence extends far beyond Earth, shaping the environments of all the planets in our solar system. The sun's radiation and magnetic field can affect the atmospheres of planets, strip away their water, and even influence their geological activity. The sun is a powerful force that shapes the destinies of all the planets in its domain. So, when we speak of the sun as the engine of life, we are not using a mere metaphor. It is a literal truth, a scientific fact supported by countless observations and experiments. The sun is the source of all energy on Earth, and without it, life as we know it would be impossible. Without the sun's constant fusion reactions, Earth would be a frozen, lifeless rock, adrift in the cold darkness of space. Our planet would be plunged into perpetual night, with temperatures plummeting to hundreds of degrees below zero. The oceans would freeze solid, and the atmosphere would collapse. Life as we know it, in all its astonishing diversity and complexity, is fundamentally solar-powered. From the simplest bacteria to the most complex animals, every living organism on Earth depends on the sun's energy, either directly or indirectly. From the smallest microbe to the largest whale, every living thing on this planet ultimately depends on the energy generated in the heart of our star. The energy that powers our bodies, fuels our industries, and sustains our civilization all originates from the sun's nuclear fusion reactions. This documentary will explore this profound dependency, revealing how the sun's processes have shaped, and continue to shape, the story of life on our remarkable blue planet. We will delve into the science behind the sun's energy production, explore its influence on Earth's climate and ecosystems, and examine the ways in which life has adapted to harness the sun's power. Join us on this journey to understand the vital connection between our star and our planet, a connection that is essential for our survival and our future. We will uncover the secrets of the sun, revealing its hidden complexities and its profound impact on our world. Since the dawn of human consciousness, the sun has been an object of awe, reverence, and wonder. It has captivated our imaginations, fueled our myths, and dictated the very rhythm of our lives. From the moment our eyes first opened to its radiant light, the sun has been a constant presence, a silent guardian watching over our world. Its daily journey across the sky has been a source of both comfort and mystery, a symbol of hope and renewal. Our earliest ancestors, looking up at the sky, recognized its paramount importance. They understood instinctively that their survival was inextricably linked to the sun's presence. Without its warmth and light, the world would be a cold, dark, and barren place. They saw the sun as more than just a celestial object. It was a life-giver, a source of sustenance, and a powerful force that shaped their world. They saw it as a powerful deity, a giver of life, a celestial clock that governed the seasons and the cycles of growth and harvest. The sun dictated when to plant, when to harvest, and when to prepare for the harshness of winter. Its movements were carefully observed, its patterns meticulously recorded, and its influence deeply ingrained in their culture and beliefs. The sun was the ultimate timekeeper, its rising and setting marking the passage of days, months, and years. Cultures across the globe, from the ancient Egyptians with their sun god Ra, who was believed to travel across the sky in a solar bark, bringing light and warmth to the land, to the Incas who worshipped Inti, believing him to be the ancestor of their royal family and the source of all life in the Andes, and the Aztecs with Huitzilopochtli, the war god associated with the sun, who required constant nourishment through ritual sacrifice to ensure its continued journey across the sky. All developed rich mythologies and elaborate rituals centered around the sun. These rituals often involved offerings, prayers, and ceremonies designed to appease the sun god and ensure its continued favor. Temples were built to honor the sun, and festivals were held to celebrate its power and influence. The sun was not just a celestial object, it was a living, breathing entity that demanded respect and reverence. These ancient civilizations understood in their own way the sun's vital role in their survival and prosperity. Its power to nurture crops, providing the energy needed for plants to grow and flourish, ensuring a bountiful harvest, banish the darkness, chasing away the shadows of night, and bringing forth the light of a new day, and bring warmth to the world. The sun's warmth was essential for survival, protecting them from the cold and allowing them to thrive in otherwise inhospitable environments. It was a source of comfort, a symbol of hope, and a reminder of the life-giving power of the natural world. These early observations, though often cloaked in myth and legend, were humanity's first attempts to understand our star. They tracked its movements meticulously, charting its course across the sky with remarkable accuracy, using simple tools and their keen powers of observation. They noticed the subtle changes in its position throughout the year, and they began to connect these changes to the changing seasons. Building sophisticated observatories like Stonehenge, a testament to their ingenuity and their deep understanding of the sun's movements, or Newgrange, aligning their structures with solstices and equinoxes, creating sacred spaces that marked the passage of time and celebrated the sun's power. These structures served as both observatories and temples, places where they could connect with the sun and honor its life-giving energy. They noted its patterns, its apparent journey across the sky, and its connection to the changing seasons. They understood that the sun's position in the sky was not random. It followed a predictable path that could be used to predict the arrival of spring, summer, autumn, and winter. This knowledge was essential for their survival, allowing them to plan their agricultural activities and prepare for the challenges of each season. This ancient wisdom, born from careful observation over countless generations, laid the groundwork for a more scientific approach. The questions they asked: what is the sun? What is it made of? How does it influence our world? How does it shine? What is the source of its seemingly endless energy? What is its place in the cosmos? How does it compare to other stars in the vast expanse of the universe? Are questions that continue to drive scientific inquiry today, pushing us to explore the mysteries of the sun with ever greater precision and sophistication. albeit with far more advanced tools and understanding. We now have telescopes that can observe the sun in unprecedented detail, spacecraft that can fly close to its surface, and sophisticated computer models that can simulate its complex behavior. The transition from mythological reverence to scientific understanding has been a long and fascinating journey. Thinkers and astronomers through the ages, from Anaxagoras in ancient Greece, who proposed the sun was a giant, incandescent stone, challenging the prevailing belief that it was a divine being, to Copernicus, who placed it at the center of our solar system, revolutionizing our understanding of the universe and challenging the long-held geocentric view, gradually peeled back the layers of mystery. Each new discovery built upon the previous one, leading us closer to a more accurate and complete understanding of the sun. Galileo Galilei, using his newly invented telescope, observed sunspots, providing the first evidence that the sun was not a perfect, unchanging sphere, as had been previously believed, revealing that the sun was not a perfect, unchanging orb. It was a dynamic, active body with blemishes and imperfections. Each discovery, each new theory, brought us closer to understanding the true nature of our star, its composition, its behavior, and its place in the universe. It marked a profound shift in human perspective, moving from a geocentric to a heliocentric view of our local cosmos. This shift not only changed our understanding of the sun, but also our understanding of our place in the universe. We were no longer at the center of everything. We were just one planet orbiting a star, among countless other stars in the vast expanse of space. Today, armed with the principles of physics, astrophysics, and cosmology, we understand the sun with unprecedented detail. We know it is a G2V-type star, a yellow dwarf, a relatively common type of star in our galaxy, but one that is perfectly suited to supporting life on Earth. We comprehend the nuclear fusion processes powering it, the immense pressure and temperature at its core that force hydrogen atoms to fuse together, releasing vast amounts of energy, its internal structure, with its core, radiative zone, and convective zone, and its complex magnetic fields, which are responsible for many of the sun's dynamic phenomena that give rise to phenomena like solar flares and coronal mass ejections. These events can have a significant impact on Earth, disrupting our communication systems and even causing power outages. Understanding these phenomena is crucial for protecting our technology and ensuring our safety. Spacecraft now fly close to the sun, sampling its particles and imaging its surface in incredible detail. These missions provide us with invaluable data about the sun's composition, its magnetic field, and its interaction with the solar wind. They are helping us to unravel the mysteries of our star and to better understand its influence on our planet. Yet, even with all our modern knowledge, that sense of awe remains. The more we learn about our sun, the more remarkable it appears, a complex and dynamic object that continues to surprise and challenge us. Its beauty is undeniable, its power is immense, and its influence on our lives is profound. A testament to the enduring power of nature and the relentless curiosity of the human spirit. Our quest to understand the sun is a journey that has spanned millennia, and it is a journey that is far from over. As we continue to explore the mysteries of our star, we will undoubtedly uncover new wonders and gain a deeper appreciation for its vital role in our lives and in the universe. This documentary invites you on an extraordinary journey, a voyage into the heart of a star's existence. We will embark on a quest to understand the sun, not just as the radiant orb that graces our skies, but as a dynamic entity with a rich history and a compelling future. Prepare to be amazed by the sheer scale of time and the intricate processes that govern the life of a star. A voyage spanning not just centuries or millennia, the familiar markers of human history, but eons, epochs of time so vast they challenge our comprehension. We're talking about timescales that dwarf the existence of civilizations, the rise and fall of empires, and even the entirety of the human species. This is a journey into deep time, a realm where the rules are different and the pace is almost imperceptible, but billions of years. We're talking about a time frame that stretches back to the very formation of our solar system, to the primordial soup from which our planet and all life on it emerged. To truly grasp the sun's story, we must expand our minds and embrace the immensity of cosmic time. We will trace the complete life cycle of our sun, from its humble beginnings to its inevitable demise. We will witness the stages of its evolution, the transformations it undergoes, and the profound impact it has on its surrounding environment. This is a story of birth, life, and death, played out on a cosmic stage. From its very beginnings in a vast cloud of interstellar gas, a swirling nebula of hydrogen, helium, and trace elements, the raw materials of star formation. These clouds, often light years across, are the stellar nurseries where stars are born. They are regions of intense activity, where gravity and turbulence conspire to create new suns, and dust, microscopic particles of heavier elements forged in the hearts of dying stars and scattered across the galaxy. This cosmic dust plays a crucial role in the formation of stars and planets, acting as seeds around which matter can coalesce. It is the stardust from which we are all made. Through its long, stable adulthood, a period of relative calm and consistency, where the sun shines brightly and steadily, providing the energy that sustains life on Earth. This is the main sequence phase, the longest and most stable part of a star's life, a time of equilibrium between gravity and nuclear fusion, and into its distant, dramatic future, a future filled with change and transformation, as the sun exhausts its fuel and begins its descent towards stellar death. This future holds the promise of a red giant phase, a planetary nebula, and ultimately, a white dwarf, the final embers of a once mighty star. It is a story of cosmic proportions, a tale that unfolds on a scale that is almost impossible to comprehend. The distances involved are measured in light years, the speeds in kilometers per second, and the masses in multiples of our own sun. This is a universe of extremes, where the ordinary is dwarfed by the extraordinary. An epic narrative that unfolds on timescales almost too vast for the human mind to fully grasp. We struggle to imagine millions, let alone billions, of years. Yet, this is the timescale on which the universe operates, the timescale on which stars are born, live, and die. To understand the sun, we must learn to think in terms of cosmic time. Our own lives, even the entire span of recorded human history, are but fleeting moments in the grand lifespan of our star. We are mere blips on the cosmic radar, our existence a brief spark in the vast darkness of time. Yet, within this fleeting moment, we have the capacity to understand the universe and our place within it. To understand the sun, we must learn to think in deep time, to stretch our minds beyond the familiar boundaries of human experience, and embrace the immensity of cosmic history. We must learn to see the sun not as a static object, but as a dynamic entity evolving over billions of years. Our journey begins approximately 4.6 billion years ago, a time when the Earth was still a molten ball of rock and the solar system was a chaotic swirl of dust and gas. This is the starting point of our story, the moment when the sun began its long and eventful life. At this time, in a quiet spiral arm of the Milky Way galaxy, a region far from the galactic center and its intense radiation, the conditions were just right for the formation of a new star. This spiral arm, a swirling river of stars and gas, provided the perfect environment for the sun's birth. The conditions were ripe for the birth of a new star and its accompanying planetary system. A dense cloud of gas and dust, a stellar nursery, began to collapse under its own gravity, setting in motion the chain of events that would lead to the formation of our sun and the planets that orbit it. We will explore how a cold, dark molecular cloud, a vast reservoir of hydrogen and helium, shielded from the harsh radiation of nearby stars, provided the raw materials for the sun's creation. These clouds are the coldest and densest regions of interstellar space, the ideal breeding grounds for stars. Under the influence of gravity and perhaps triggered by a nearby cosmic event, began to collapse. A supernova explosion, a shockwave from a distant star, or even the passage through a dense region of the galaxy could have provided the initial push that started the collapse. This collapse marked the genesis of our solar system, the beginning of a long and complex process that would ultimately lead to the formation of the sun, the planets, and all the other objects that populate our cosmic neighborhood. It was a pivotal moment in the history of our galaxy, the very first chapter in the sun's long existence. As the cloud collapsed, it began to spin faster and faster, forming a swirling disk of gas and dust. At the center of this disk, the densest region began to heat up, marking the birth of a protostar, the Sun in its infancy. We will witness the formation of a protostar, a stellar embryo, a ball of gas and dust slowly gathering mass and energy. This protostar was not yet a true star, as it lacked the nuclear fusion that powers mature suns. It was a star in the making, a promise of things to come. Gradually heating up as more material fell inwards, drawn by the ever-increasing gravitational pull. This process, known as accretion, was crucial for the protostar's growth, as it steadily accumulated mass and density. The infalling material also carried angular momentum, causing the protostar to spin faster and faster, until the conditions in its core became extreme enough to ignite the fires of nuclear fusion. This was the moment of ignition, the point at which the protostar transformed into a true star. Hydrogen atoms began to fuse together, releasing tremendous amounts of energy and marking the birth of our Sun. Once ignited, our Sun entered its main sequence phase, a period of stability and equilibrium that would last for billions of years. This is the phase in which the Sun spends most of its life, steadily burning hydrogen and providing energy to the solar system. The long, stable period of adulthood it currently enjoys. During this phase, the Sun's energy output remains relatively constant, providing a stable environment for the development of life on Earth. It is a period of cosmic harmony, a delicate balance between gravity and nuclear fusion. For billions of years, it has been steadily converting hydrogen into helium, a process that releases vast amounts of energy in the form of light and heat. This nuclear fusion is the engine that powers the Sun, the source of its radiant energy, providing a consistent source of energy for its burgeoning family of planets, including our own Earth. This energy is essential for life as we know it, driving the Earth's climate, powering photosynthesis, and providing warmth and light. The Sun is the lifeblood of our planet. This stability has been crucial for the development and evolution of life. The consistent energy output of the Sun has allowed life to flourish on Earth, providing a stable environment for complex organisms to evolve. Without this stability, life as we know it would not be possible. But stars are not eternal. Like all things in the universe, they are subject to the laws of physics and the inevitable march of time. Stars, too, must eventually face their demise. Just as they are born, they must also age and eventually die. The process of stellar death is a dramatic and transformative event, marking the end of a star's life and the beginning of a new chapter in the cosmic cycle. Our Sun is now roughly middle-aged, having spent about half of its main sequence lifetime burning hydrogen. It is a mature star in the prime of its life, but its future is already determined by the laws of physics. With billions of years still ahead of it, but its future evolution is already charted by the laws of physics. As the Sun continues to burn hydrogen, its core will gradually shrink and heat up, leading to a series of dramatic changes in its structure and energy output. We will explore this future looking ahead to the changes it will undergo, the transformations it will experience, and the impact it will have on the solar system. We will witness the Sun's journey towards its eventual demise. This exploration of the Sun's entire lifespan, from its initial formation to its final fate, provides a complete picture of its existence, a comprehensive understanding of its role in the universe. From its fiery birth to its eventual fading as a white dwarf, a small, dense remnant of its former self offers a glimpse into the ultimate destiny of our star. This is the final chapter in the Sun's story. The end of its long and eventful life offers a profound perspective on our place in the cosmos. By understanding the Sun's life cycle, we gain a deeper appreciation for the vastness of time and the interconnectedness of all things in the universe. It reminds us that even the most seemingly permanent features of our experience, like the sun in our sky, the constant source of light and warmth that sustains life on Earth, are part of a larger, ever-changing cosmic drama. The universe is in a constant state of flux, with stars being born, living and dying in an endless cycle of creation and destruction. By understanding the sun's past, present and future, we can begin to unravel the mysteries of stellar evolution and gain a deeper understanding of the universe around us. We gain a deeper appreciation for the immense forces that shape the universe, the fundamental laws of physics that govern the behavior of matter and energy on a cosmic scale, and the intricate web of connections that link us to the stars. We are all made of stardust, the remnants of long-dead stars that have scattered their elements across the galaxy. Prepare to witness the grand sweep of stellar evolution, a story that spans billions of years and encompasses the birth, life, and death of stars. A story written in the language of gravity, the fundamental force that shapes the universe and governs the motion of celestial objects. Matter, the building blocks of the universe, the raw materials from which stars and planets are formed. And energy, the driving force behind all cosmic processes, the fuel that powers the stars and illuminates the universe. Join us as we delve into the epic timeline of our sun. The connection between humanity and the sun is far more profound than simply enjoying a sunny day at the beach, feeling its warmth on our skin, or relying on it for light to illuminate our world. It goes beyond the superficial and delves into the very essence of our being. It's a relationship that has shaped our planet, molded our evolution, and continues to influence our daily lives in countless ways, both seen and unseen. We often take the sun for granted, a constant presence in our sky, but its role is far more significant than we often realize. Our relationship with this star is woven into the very fabric of our existence, influencing every aspect of our planet and our lives. It's a cosmic dance that began billions of years ago, a partnership that has allowed life to flourish on Earth. From the smallest microbe to the largest whale, every living thing owes its existence, in some way, to the energy provided by the sun. This isn't just a scientific observation. It's a fundamental truth that connects us all to something far greater than ourselves. From the grand scale of global climate patterns, the swirling dance of weather systems across continents, to the microscopic processes within our own cells, the sun's influence is pervasive and inescapable. It dictates the temperature of our planet, drives the winds and ocean currents, and fuels the very engine of life itself. Without the sun, Earth would be a frozen, barren wasteland, devoid of the vibrant ecosystems and diverse life forms that we know today. It is not merely a distant celestial body, a passive source of light and heat. It is an active participant in the ongoing story of Earth, a constant presence that has shaped our world and everything within it for billions of years. The sun is a dynamic and ever-changing entity, constantly emitting energy and influencing the space around it. Solar flares, coronal mass ejections, and the solar wind are all manifestations of this activity, impacting Earth's magnetic field and even our technological infrastructure. We are, in a very real sense, creatures of the sun, molded by its energy and dependent on its continued existence. Consider the Earth's climate system, a complex and interconnected web of processes that regulate our planet's temperature and weather patterns. The uneven heating of our planet's surface by solar radiation drives the winds, creating the atmospheric circulation that distributes heat around the globe. Warm air rises at the equator, travels towards the poles, cools, and then sinks back down, creating a continuous cycle of air movement. This circulation is responsible for everything from the trade winds that propelled sailing ships across the oceans to the jet streams that influence our daily weather. The ocean currents, vast rivers of water flowing through the world's oceans, are also driven by solar energy. The sun heats the surface waters, causing them to expand and become less dense. This warm water flows towards the poles, where it cools and becomes denser, sinking to the bottom and flowing back towards the equator. This process, known as thermohaline circulation, plays a crucial role in regulating global temperatures and distributing nutrients throughout the marine ecosystem. And the water cycle, the continuous movement of water between the Earth's surface, atmosphere, and oceans, is also powered by the sun. Solar energy evaporates water from oceans, lakes, and rivers, turning it into water vapor that rises into the atmosphere. This water vapor then condenses to form clouds, which eventually release precipitation in the form of rain, snow, or hail. This precipitation replenishes our freshwater sources, providing the water we need for drinking, agriculture, and industry. These phenomena, in turn, create the diverse climates and weather patterns that define different regions of our world, from tropical rainforests teeming with life and biodiversity, where abundant rainfall and warm temperatures support lush vegetation and a vast array of animal species, to icy polar deserts, where extreme cold and limited sunlight restrict plant growth and only the hardiest animals can survive. The sun's influence is felt in every corner of our planet, shaping the landscapes and ecosystems that we see around us. The changing seasons, a fundamental rhythm of life in many parts of the globe, are a direct consequence of Earth's tilted axis as it orbits the sun. As Earth travels around the sun, different parts of the planet are exposed to varying amounts of sunlight, leading to the cyclical changes in temperature and daylight hours that we experience as seasons. This cycle influences everything from plant growth and animal behavior to human activities and cultural traditions. Every weather forecast we hear, every agricultural cycle, every migration pattern of animals is ultimately tied to the energy our planet receives from its parent star. Farmers plant their crops in the spring, when the days are getting longer and the sun is providing more energy for growth. Animals migrate to warmer climates in the winter, seeking food and shelter in areas where the sun's energy is more abundant. Even our daily routines are influenced by the sun, as we tend to be more active during the day and sleep at night. Beyond the physical environment, the sun's energy is the bedrock of Earth's biosphere, the realm of life on our planet. The process of photosynthesis, performed by plants, the green architects of our world, algae, the microscopic powerhouses of the ocean, and some bacteria, the tiny but mighty organisms that inhabit every corner of our planet, captures sunlight and converts it into chemical energy, forming the base of almost all food chains on our planet. This remarkable process is the foundation of life as we know it, providing the energy that fuels all living organisms. The oxygen we breathe, the very air that sustains us, is a byproduct of this incredible solar-powered chemistry. As plants, algae, and bacteria convert sunlight into energy, they release oxygen as a waste product. This oxygen has accumulated in our atmosphere over billions of years, creating the conditions that allow animals, including humans, to thrive. Every meal we eat, whether plant or animal, can be traced back to the sun's energy, a testament to the interconnectedness of life on Earth. This intimate biological connection underscores how life on Earth is fundamentally adapted to and dependent upon the consistent and life-sustaining output of our star. From the smallest insect to the largest mammal, every organism has evolved to take advantage of the sun's energy in some way. Our very metabolism is tuned to this stellar energy, our bodies designed to function optimally in the presence of sunlight. Even our daily rhythms are governed by the sun. The cycle of day and night, dictated by Earth's rotation, influences the behavior and physiology of countless species, including our own. Animals are active during the day or night, depending on their adaptations and ecological niche. Plants open and close their leaves in response to sunlight. And humans, too, are deeply affected by the daily cycle of light and darkness. Our sleep-wake cycles, known as circadian rhythms, are synchronized by sunlight. These internal biological clocks regulate a wide range of physiological processes, including hormone production, body temperature, and alertness. Sunlight helps to keep our circadian rhythms aligned with the 24-hour day, ensuring that we are awake and alert during the day and able to sleep soundly at night. Disruptions to our circadian rhythms, such as those caused by jet lag or shift work, can have negative impacts on our health and well-being. Throughout history, the sun has also been our primary means of timekeeping and navigation. Before the invention of clocks and compasses, humans relied on the sun's position in the sky to determine the time of day and their direction of travel. Sundials, ancient instruments that use the sun's shadow to measure time, have been found in cultures around the world. And sailors have long used the sun to navigate the oceans, relying on its position to determine their latitude and longitude. Thus, our connection to the sun is not just physical or biological, but also deeply ingrained in our culture and our perception of the world. The sun has been worshipped as a deity in many cultures throughout history, representing life, energy, and power. It has inspired countless works of art, literature, and music, and it continues to hold a special place in our collective consciousness, a symbol of hope, warmth, and renewal. Understanding this intricate and multifaceted relationship is key to appreciating the full significance of the star that dominates our sky. the star that has shaped our planet and made life on Earth possible. It is a connection that binds us to the cosmos, reminding us that we are all part of something far greater than ourselves. As we conclude this introduction, we arrive at one of the most profound concepts in all of science, a concept that resonates with our very being and challenges our understanding of existence. It's a realization that blurs the lines between the cosmic and the personal, inviting us to contemplate our place in the grand tapestry of the universe. This isn't just about astronomical distances or complex physics. It's about the fundamental building blocks of reality and how they came to be. A truth that connects us not only to our sun, the radiant orb that sustains life on Earth, but to the entire universe, to every star that twinkles in the night sky, to every galaxy swirling in the cosmic void. It's a connection that transcends time and space, linking us to events that occurred billions of years ago and light years away. This connection is not merely metaphorical, it's a tangible link forged in the heart of stars. It is the understanding that we are, quite literally, children of the stars, beings composed of elements that were created in the nuclear furnaces of distant suns. This isn't just a romantic notion, it's a scientific revelation that has transformed our understanding of our origins. We are not separate from the cosmos, we are an integral part of it, a product of its evolution, a testament to its creative power. The very atoms that make up our bodies, the fundamental units of matter that define our physical form, are not primordial. They weren't present at the beginning of the universe. They are the result of a complex and fascinating process that unfolded over billions of years within the hearts of stars. Each atom has a story to tell, a journey that spans cosmic epochs. The calcium in our bones, the very substance that gives us structure and support, allowing us to stand upright and move through the world, was forged in the intense heat and pressure of a dying star. It's a humbling thought that the strength that allows us to experience life comes from such a cataclysmic event. The iron in our blood, the vital element that carries oxygen throughout our bodies, fueling our cells and enabling us to breathe, was created in the core of a massive star on the brink of supernova. Without this iron, transported across the cosmos and incorporated into our planet, life as we know it would be impossible. The carbon that forms the basis of all life as we know it, the backbone of every organic molecule, the element that allows for the incredible complexity and diversity of living organisms, were not created on Earth. It's a cosmic ingredient, cooked up in stellar ovens and scattered across the universe. These elements were forged in the fiery hearts of stars that lived and died long before our sun itself was born. Stars that blazed with unimaginable intensity and then vanished in spectacular explosions, leaving behind a legacy of newly created elements. These stellar ancestors paved the way for our existence. This is a legacy written in the elements, a direct lineage to the cosmic furnaces of previous stellar generations, a testament to the cyclical nature of the universe, where death and destruction give rise to new beginnings. We are the beneficiaries of this cosmic recycling process, inheriting the gifts of long-dead stars. The early universe, born from the Big Bang, was incredibly simple, composed almost entirely of hydrogen and helium, the lightest and most abundant elements in existence. It was a blank canvas, a primordial soup from which all the complexity of the cosmos would eventually emerge, with tiny traces of lithium, a light metal that barely hinted at the chemical richness that was to come. This early universe was a far cry from the vibrant and diverse cosmos we see today. It lacked the essential ingredients for life as we know it. The heavier elements essential for life: carbon, the foundation of organic chemistry, the element that allows for the formation of complex molecules and intricate structures; oxygen, the breath of life, the element that powers our metabolism and allows us to extract energy from food; nitrogen, a crucial component of DNA and proteins, the building blocks of life, the element that helps regulate our planet's atmosphere, and many others, were virtually non-existent. The universe was missing the key ingredients for building planets, for creating life, for fostering complexity. It was a universe of potential, waiting for the spark of stellar creation. These elements were painstakingly created over billions of years through the process of stellar nucleosynthesis. a series of nuclear reactions that transformed lighter elements into heavier ones within the cores of stars. It's a cosmic alchemy, a process that turned simple gases into the building blocks of life. Massive stars, far larger than our Sun, lived fast and died young, burning through their fuel at an astonishing rate and forging heavier elements in their intense cores. These stellar giants were the cosmic foundries that enriched the universe with the raw materials for life, fusing lighter elements into heavier ones within their cores, a process that released tremendous amounts of energy and created the elements that would eventually form planets and life. This nuclear fusion is the engine that powers the stars and drives the evolution of the universe. When these stars exhausted their fuel, they exploded as spectacular supernovae, cataclysmic events that released more energy than our Sun will produce in its entire lifetime. These explosions were not just destructive, they were also creative, scattering newly forged elements across the cosmos. Scattering these newly forged elements across the vastness of space, enriching the interstellar medium, and providing the raw materials for future generations of stars and planets. These supernova remnants are the cosmic recycling centers, dispersing the elements created within stars back into the universe. These stellar explosions enriched the interstellar medium, the gas and dust between stars, the vast and diffuse reservoir of matter that permeates galaxies. This enrichment was crucial for the formation of new stars and planets capable of supporting life. With the raw materials for new generations of stars and planets, providing the building blocks for new worlds and the potential for life to emerge. These stellar nurseries are the birthplaces of stars and planets, where gravity and time conspire to create new cosmic entities. Our Sun is a third-generation star, a relative newcomer to the cosmic scene, but a vital component of our solar system. It's a star that inherited the legacy of previous generations, a star that contains the elements necessary for life, meaning it formed from a cloud of gas and dust that already contained these heavier elements, a cosmic inheritance from stars that came before, a testament to the interconnectedness of the universe. Our Sun is not an isolated entity, it's part of a larger cosmic family. And from the remnants of the Sun's birth cloud, the Earth and the other planets in our solar system were formed, coalescing from the swirling dust and gas that surrounded the young Sun. These planets are the children of the Sun, inheriting its composition and its destiny. Therefore, the elements that make up our planet, the air we breathe, the water we drink, and our own bodies, have an ancient stellar pedigree, a lineage that stretches back to the earliest stars in the universe. We are connected to the cosmos in a profound and tangible way. We are composed of recycled stardust, the remnants of long-dead stars that have been scattered across the universe and reassembled into new forms. We are the living embodiment of cosmic recycling. This concept, that we are made of star stuff, as the famous astronomer Carl Sagan eloquently put it, captures the essence of our cosmic connection, reminding us that we are not separate from the universe, but an integral part of it. It's a humbling and awe-inspiring realization. It's not just a poetic notion, it is a scientifically established fact, supported by decades of astronomical observations and theoretical models. It's a truth that has been revealed through the painstaking work of scientists around the world. It means that our story is inextricably linked to the life cycle of stars, to their birth, their life, and their death. We are part of a cosmic drama that has been unfolding for billions of years. The birth, life, and death of stars are not distant, abstract events. They are fundamental processes that have shaped the universe and made our existence possible, creating the elements that make up our bodies and our planet. These stellar processes are the foundation of our existence. As we embark on this journey to understand the life of our Sun, we are also exploring our own deepest origins, tracing our ancestry back to the stars and uncovering the secrets of the universe. It's a journey of discovery that will transform our understanding of ourselves and our place in the cosmos, uncovering the cosmic chain of events that led to us, here, now, on this small blue planet, looking up and wondering about the stars, marveling at the vastness and complexity of the universe, and recognizing our profound connection to it all. We are the universe contemplating itself, Stars may appear eternal, steadfast beacons in the night sky, but even the mightiest of them have lifespans. Our sun, too, is not immortal. Its brilliance is only a chapter in a much longer story, one that began billions of years ago and will, inevitably, draw to a close. Since its fiery birth, the sun has been slowly growing brighter, a change invisible to us in a single lifetime, but relentless over eons. This inexorable increase in energy is the ticking clock of our planet's habitability. In about 1 billion years, the sun's intensified luminosity will tip Earth into a runaway greenhouse effect. Oceans will evaporate, the atmosphere will thicken with steam, and our blue planet will become inhospitable, a parched relic scorched by its aging star. But the sun's transformation doesn't end there. In roughly 5 billion years, it will exhaust its core supply of hydrogen, the fuel that has sustained its warmth and light. Deprived of this energy, the sun's core will contract and heat up, causing its outer layers to swell. The sun will balloon into a red giant, a cosmic colossus so vast that it may engulf Mercury and Venus and perhaps even graze Earth's orbit. Our familiar sun will become a crimson titan, painting the sky with its dying glow. Inside this bloated star, temperatures will soar to a staggering 100 million degrees Celsius, igniting the helium flash, a dramatic burst of fusion at the sun's core. For a brief epoch, helium will fuse into heavier elements, fueling a final, unstable phase. Ultimately, the sun will shed its outer layers in a spectacular display, creating a glowing shell of gas, a planetary nebula, while its heart remains behind as a dense, white-hot ember, a white dwarf. This stellar remnant, no larger than Earth but unimaginably dense, will slowly cool and fade over trillions of years, destined to become a cold, dark black dwarf, a silent monument to a once vibrant star. Yet even in death, the sun's story is not one of loss, but of renewal. The elements cast off in its final moments will enrich the interstellar medium, seeding future generations of stars, planets, and perhaps even life. The cycle continues. The universe reclaims its stardust and begins anew. The sun's fate is a solemn reminder: nothing in the cosmos is truly permanent. But from every ending comes the promise of new beginnings, etched in the stars, written in the very atoms that make us who we are. As we look up at the sun, we are reminded of a profound truth: our connection to this star is deeper than light and warmth. It is written in the very atoms of our bodies, the carbon in our cells, the oxygen we breathe, the calcium in our bones, and the iron in our blood. These elements were forged in the hearts of ancient stars, long before our sun was born. As Carl Sagan so beautifully said, we are made of star stuff. This is not just poetry, but scientific fact. The atoms that make us were created in stellar furnaces, scattered across the cosmos, and gathered into new worlds. One day, our sun will return some of its own material to the interstellar medium, enriching the galaxy and seeding the birth of future stars and planets. The cycle of creation continues, but the sun's finite lifespan is also a reminder. Our time on Earth is not unlimited. If humanity is to endure, we must one day reach beyond our home, becoming interplanetary, perhaps even interstellar. Consider the journey of a single photon, born in the sun's core. It spends thousands of years bouncing through dense plasma, finally escaping into space, traveling across the void and reaching Earth, where it may warm your face or nourish a leaf. We are not separate from the universe, but intimately connected to it, especially to the star that has nurtured life on our planet for billions of years. Our story is the sun's story, and the sun's story is the universe's story. As we continue to explore, to wonder, and to reach for the stars, let us remember, we are, and always will be, children of the sun. As we conclude our cosmic journey through the life of our sun, we invite you to ponder your own connection to the stars above. What aspects of our sun's incredible story resonated most with you? Share your thoughts in the comments below and join our growing community of the Physics and Cosmos Academy. If you enjoyed this voyage through space and time, subscribe for more captivating documentaries that unravel the mysteries of our universe, from distant galaxies to the wonders of our solar system. The cosmos holds countless stories waiting to be told, and we're just getting started. Stay tuned for our next astronomical adventure.